Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Dean Stewart from Thermo Fisher Scientific.
Hello everyone, and welcome to the webinar. Thank you for taking the time to attend. My name is Dean Stewart, and today I will present a new use for TrueScan RM, using the Handheld Raman along with the TrueTools suite of chemometric algorithms to identify chemically defined media. We'll discuss how Raman, specifically the TrueScan RM and TrueTools, provide significant quality improvements in the critical workflow of biologic drug production. The agenda is pretty straightforward. With the limited time I have, I'll speak about chemically defined cell culture media and customized algorithms for enhanced material inspection of biologically relevant materials using Raman spectroscopy. I'll also briefly describe our capabilities with identifying reconstituted liquid medias from one another. The TrueTools software add-on is an upgrade for any TrueScan RM, and it includes accompanying IQOQ documentation for GMP compliance. It offers the ability to generate customized qualitative and quantitative methods, and the software itself resides on the TrueScan RM. It's used in virtually identical fashion as our classic interface. This is open to many biopharmaceutical applications for Raman spectroscopy, utilizing the existing hardware, which our customers already own anyway. This is an incredibly effective way to expand the utility of the TrueScan RM and realize even greater efficiencies. TrueTools is designed to assist in scenarios where our standard TrueScan algorithm doesn't collect to a high enough signal-to-noise ratio to specifically ID highly similar materials, or separately when you have a quantitative application. A TrueScan RM method developer can now set the laser power, the exposure time, and the number of coads for spectral acquisition just like a benchtop instrument. The analyzer automatically outputs SPC files, which can be directly dropped into the Eigenvector Research Solo Chemometrics package, so you can define spectral range of interest, pre-process the spectra, choose your chemometric algorithm, and process your model. The interface within the chemometric software also helps you test the model for further validation purposes. The PLS, a PCA, PCR, or PLSDA model is exported as a script and is embedded in the specific TrueTools method as the instructions for data analysis. The custom TrueTools method will then produce qualitative or quantitative results on board the TrueScan and synchronize all the required reports. In short, analysis can be tailored for challenging incoming raw materials which you may have heard of, polysorbates, PEGs, poloxamers, which may vary in molecular weight distribution, or as the topic of this quick discussion, for complex formulation of materials like chemically defined media. So using the TrueScan to perform a fingerprint identification of chemically defined media allows for rapid and mobile analysis both in and outside of the lab without the need for direct sample contact. Models made on one analyzer can be deployed quickly on other TrueScans for quick method deployment across multiple sites and facilities. And as you'll see, dry powder cell culture media is an interesting opportunity for TrueTools. Many of these media are finely adjusted proprietary formulations, and they appear visually quite similar. We asked our colleagues in the bioproduction division to send us some closely related media. The chemically defined media are a great prospect for the TrueScan RM as their native fluorescence is relatively low. While media segregation had been a problem previously for some manufacturing sites, it appears that advanced granulation technologies are making that problem much less of an issue. And here we have the mean spectra of 4 different media you may be familiar with as listed in the legend above. I consider these to be the spectral fingerprints of each unique media. The samples were measured through glass vials with a total analysis time of less than 2 minutes each. And as you can see, the green and gold spectra are quite similar, as are the blue and the red. Note the blue and red spectra show differences in relative magnitudes of their peak intensities, while the green and gold spectra display the presence of some potentially different constituents. The slight differences in these pairs of spectra are, again, the reason why we utilize TrueTools to increase the signal-to-noise ratio and extract the finer details with classical chemometric approaches. The formulations are proprietary, so I'm unable to say what the chemical differences actually are, but I am able to transform the samples into valuable information displayed on the scores PCA plot. And remember, the red and the blue spectra appear to be the most chemically similar. So using a standard normalization, derivatization, and mean centering of the data, a 3-component PCA model looks like this in a scores plot. This result is based on 25 samples of each batch of media. And we're building this out more fully with a greater number of batches to further identify changes to the media from light, moisture ingress, and storage conditions. So note that, the horizontal axis accounts for about 60% of the variance, while the vertical axis accounts for 16% of the variance. And these magnitudes should be considered when you visualize score plots. But remember, the red and the blue groups, clusters, the glycan tune B plus and the efficient feed B plus are very similar. So let's drill down on those two specifically. Really quickly, here's our measurement protocol for looking closer at the glycan tune B plus and the efficient feed B plus. 2 different media types and 4 batches, so 2 of each, are interrogated in glass vials. In total, 12 scans are collected per batch of media, and we also see the scan parameters that were chosen using TrueTools' method setup option. 250 milliwatts laser power, so high-powered laser, 5,000 millisecond exposure time, so 5 seconds, and 10 coads per analysis. So looking at the mean spectra for each batch, we see 4 spectra as expected, 2 for each batch, and can readily see the spectral similarities along with some very minor differences around 500 and 700 wave numbers, and also some shoulder peak differences near 1250. This all goes to say, once again, these two are very extremely similar media. As part of building the mathematical model, the data is worked up offline in eigenvector solo, and we can see immediately that there is separation among the media types, and very little separation within a given batch. Indeed, right, each respective batch aligns closely with the other batch of the same media type. Overall, our mathematical model is able to differentiate the unique spectral fingerprints from one another. And for this particular study, again, we used standard normal variance, a first derivative, and mean centering for the pre-processing. So instead of looking at each batch individually, let's combine the batches into specific classes. And let's call those classes GT for glycan tune B+, and EF for efficiency B+. And here we see the mean spectra of 24 scans per batch defined by those 2 classes. Once this spectral information is pre-processed using eigenvector solo, we see again, this time with more discrete class distinction, separation of the 2 types of media. Because of TrueTools, we're able to show that those 2 very spectroscopically similar media are in fact quite different from one another. And when deployed on the TrueScan, this model will display either a pass or a fail result for the identification, similar to what current TrueScan RM users have enjoyed with the native p-value algorithm. So let's take a quick look at the reconstituted forms of these medias. For this study, the TrueScan acquisition parameters and protocol is the same as was for the dry powdered study, and the medias themselves were prepared at 1x the normal use, so just typical normal use concentration. 59.2 gram per liter for the glycan 2B+, and 52.7 gram per liter for the efficiency B+. Very similar use concentrations and already very similar makeup. And we can see that reconstituting the medias greatly reduces the overall spectral quality for both medias compared to the dry powdered form. But even so, we can see small spectral differences around 300 wave numbers, very subtle differences near 500 inverse centimeters, and some more apparent differences closer to 900 wave numbers. But let's pre-process the data, pull out even more of those subtle differences. Same pre-processing as before, and still, we're able to well define and show class separation from both media types, even as they're reconstituted. This is significant, as performing a spot ID check on a prepared media can be critical. It can really be the critical difference between having happy, healthy cell growth or losing quite a bit of money overall. The added benefit of using TrueTools on a handheld Raman for this spot check is that it doesn't have to be performed in a single dedicated space. So in summary, we've shown how, with using TrueTools, 2 extremely similar chemically defined media formulations are easily distinguished from one another. This is an analysis that may be performed in a variety of physical locations across a biomanufacturing facility. This doesn't have to just happen in a lab. We've also specifically shown how a TrueTools PCA model is capable of showing specificity regardless of the media presentation, so whether it was dry powdered or reconstituted. A couple things we're working on currently, gathering additional batches for larger comparison studies. Adding additional batch spectra to the overall math model will also boost that model's robustness. We're also looking at longer time frame studies to observe media changes over time. I'm sure everyone on right now would love to know whether or not their media is still good. I'm doing the air quotations around good when needed the most if it's been sitting around for quite some time. Likewise, we're also looking into using some of the other TrueTools algorithm models besides just PCA to study cell line performance. Can we tell which cell culture media is best for a given cell line based on its makeup from a quick scan with a TrueScan? So in closing, we have 2 web pages here, which you can visit for more information and contact us after the webinar. I'd like to take a minute really quickly to acknowledge Eigenvector Research for the continued development of their Chemometrics software package, which we offer with TrueTools. I'd also like to thank our bioproduction division within Thermo Fisher for supplying the samples used for this application. So as Thermo Fisher has expanded quite broadly within the biopharmaceutical space, we strive to offer some innovative technologies, purchasing conveniences, and of course services. Within our portfolio of brands, and we've got a lot of them, there are people who do what you do in your companies. And we're collaborating with those people to more fully develop purpose-built applications and hardware to enhance our partnerships with you. And with that, it's time to turn our attention to the questions. Thank you all for your attendance, and it has been my honor to share this with you today.
Great, thanks, Dean. So one is testing with powder solubilized in water.
Water, yes. So reconstituted the media powder. It's been reworked up in water, high purity water.
Okay. And can it be used to identify lot variability?
Yes. So it depends on the model that you make, but yes, you can absolutely build models to track better lot-to-lot variability. Understand lot-to-lot variability ideally is very low, which would be good, but you can track that with the tool.
Yep. And is this technique approved by the Usp Eap and the FDA?
Yeah, so that's kind of a loaded question. What we have about a 10-plus year relationship with USP and EP, just using the TrueScan as an alternate ID method. One of the interesting things, a couple years back, the EP actually created some supplemental chapters specifically for Handheld Raman. So it's kind of, over time, it has gathered more and more wide acceptance. Top-tier pharmaceutical companies already are using it. As far as the FDA goes, the FDA, being the agency it is, really can't approve the TrueScan, but we kind of have almost like a tacit acceptance of it because the FDA themselves use the TrueScan. They're actually doing a lot of studies with raw material ID and actually doing finished product ID as well using the handheld. So it's pretty neat.
Great. So what sample quantity do you need?
It can vary. So what we have with the TrueScan, the spot size of its laser, since it is Raman, it's about a 2-millimeter spot size. So you want to have enough sample such that you can at least cover that spot size. If you, say, put some reconstituted liquid in a vial, maybe 1 to 2 millimeters of liquid is plenty. If you got a solid, just, again, enough to fill a vial halfway up is more than enough.
Okay. And is the chemometric parameters similar to those of the NIR software?
So with our handheld near IR, we have our own chemometrics building program, or chemometric program. It's a little bit different. It uses, I would say, probably more of a streamlined view compared to the one that we have. But yes, it's the same parameters as what you're effectively doing with Eigenvector Solo. You're setting the spectral range, you're setting the acquisition parameters of the actual instrument, you're building the algorithm that you want to use to either do an identification or do a quantitative analysis.
Okay. Can you share your thoughts on using Raman to replace growth promotion as an ID test?
I know we haven't directly studied that just yet. We're, like I said earlier, we're kind of building out what we're doing with within the biopharmaceutical space. Right now, we kind of like to stick initially with more of like the raw material part, making sure that the correct ingredients are being used where they need to be used. That's definitely another test that we could implement with the TrueScan. We just need to do some testing about it.
Okay. So I think we have time for one more question. If we don't get to your question, all these questions will be forwarded to Dean, and he can follow up with you directly after the webcast. So please continue to type them in, but this is the last one he'll be answering now. So the last question is, what laser and powder does it use? Is this flexible and can it be changed?
Yeah, so the TrueScan it's a 785 nanometer laser, so it's a red laser. And right now, within TrueTools, we have the 3 different basically power levels you can use: low power, medium power, or high power. High power is 250 milliwatts. So typically, right now, TrueScan operates at 250 milliwatts anyway. So if you need to drop the laser power down, you can, depending on the fragility or sensitivity of your material. That wasn't something you could do earlier, previously. This is something new. So.
All right. Well, thanks, Dean.
Yep, anytime. Like I said, reach out to us at sales.chemid@thermofisher.com. We can answer your other questions. And if you do have pricing questions, we can get those answered for you as well. I really appreciate your time. Thank you very much.
The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. I look forward to having you join us at future BioProcess Internationally Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.